MOU is not signed, we cannot provide you our resources. 24th August.
Hi, Tanish.
Hi, sir.
You missed last class, right?
Yeah, I had to go to PS.
Yeah, good. How was it?
We were sitting with engineering students, so very hard.
All right. What did you do?
Coding.
Coding. All right. Wonderful. Awesome. Okay. So what we did last class, last Saturday, we are supposed to do a revision of what we did last class. Now. So last class we controlled the motors, as in the robot. We had it go forward, reverse, right, and left, which you had already done the previous class. So we got everybody to do that one. So that's what happened last class. And what you see here right now is it's going forward, reverse, right, left, and then stops. Now, I've just not connected the battery and the wheels, so you're not able to see it running. We'll start eventually.
So what about these parts?
Which parts?
Like those two black boxes.
Two black boxes?
Yeah, like my father bought some parts, right?
Oh yeah, that's the battery.
Ah, okay.
Yeah, I'm gonna show. Yeah, I'm gonna show how to use those that battery right now. Okay. Let me start. Let me get the battery. Okay. Let me start. Let me get the battery. All right. So this is the battery.
This week Saturday.
This battery is a lead acid battery. It's a combination of lead and some acid that actually does a reaction for making this a battery. Okay, if you look at it closely, okay, I'm gonna just share the actual screen so it's easy for you to see the battery well. Present to everyone. I'm just gonna hide all of you from the session so it's easy. Yeah, good. All right, good. Sorry? Oh, okay, even I'm not there this Saturday. No, I was kidding. We have class this Saturday. Okay, we'll cover what we're supposed to do for today's session, and then we will discuss. Take that off. Okay, so what we did last class is use this battery. This is a custom battery that we built right for this particular workshop. It's in its beta testing stage. So you're the first guys to experiment with this battery and tell us if it's working fine or not. So this battery is a combination of two cells, which is this is 4 volts and this is 4 volts. So we put them in series, and that makes it 8 volts. Now, battery per se by default is not 8 volts. It's individually connected this way. Now you see here, the red, black, and brown here is one battery, one cell, and the orange and red here is another cell. So this is 4 volts and this is 4 volts. All I have to do is to take 8 volts is to create a short between the negative of this battery and the positive of this battery. I'm going to just show how it looks like. So we have one battery, one cell. We call one individual thing a cell. Just gonna get this here. So this is positive and this is negative. And we have another battery, another cell, with this is positive and this is negative. Now when I create a short between this and this, now what used to be 4 volts will now become 8 volts. So this is the negative and this is the positive of the new battery. Now this entire thing that you see here will become one battery with 2 cells each of 4 volts. Now this you measure here to be 8 volts. Now here we have not done that, but if you see this connector that we have given is actually a short. I'm going to zoom in. If you look at it closely, this is the positive, this is the negative, and the center 2 pins we have created a short inside. All right, so that makes whatever connector I give here to be 8 volts. Now, how does this look like? And how do I use it? Now this is because I've connected the Arduino to my computer and that's the reason why it's glowing. I just can remove the cable and it turns off. I'm just connecting the 2 wheels for us to see the rotations. On this side. Okay. Now what I've done here is actually an insulator to adjust to ensure that it doesn't touch the nuts below. I'm just going to remove this and put some. Yeah, I just seal it such that it doesn't, the metal pins here don't touch the nuts and bolts below. Okay, be good. Now, this connector that you see here is what we'll be using for the battery. Now, this battery that you see here is 8 volts and 0.5 Ah, that is 0.5 amperes. 0.5 amperes. Now, what does 0.5 amperes mean? If I'm consuming 0.5 amps of current, then this battery will last for 1 hour. If I'm consuming 0.5 amps, this battery will last for 1 hour. And most batteries don't last 1 hour. We usually use it up to about 80%, depending on the efficiency of the battery. Or some batteries are just 50%. So if you actually calculate the current taken by your motor, it's around 200 to 300 milliamps. So effectively, it's about 600 milliamps of current. So this battery should last you about 20 minutes to 25 minutes with the connections when you make it to your Arduino board. It should last you about 20 minutes. It will give you a weird behavior after it's at about 10 volts. The fix for that problem, we're going to tell you in the class. But it's going to work well until then. Now, one precaution that you have to take when you're using this battery is you're not supposed to connect it directly here. There are every chances that these two terminals, open terminals here, would touch each other, or they are on a metal connector, something like this, and they would cause a short circuit. So always ensure that this is connected to the robot and then connect the battery to this connector. Okay, I'm just going to show how we do this. Now this is the power terminal where we connect the battery. So the red is positive. I'm going to connect it here. And the black is negative. I'm going to connect it here. I'm going to tighten the screw. And then I'm going to connect the battery. Observe that there is a lock. Yeah, observe that there is a lock for this battery, so you cannot connect it reverse. The lock on the battery and the connector has to match. So when you connect this, you'll see that the board turns on. There's a light here that turns on, indicating that the board is powered up. Now Arduino is not yet powered up, primarily because I've not connected any power supply to this. There are 2 to 3 ways you could make the connection. One connection would be to use the 5 volts and ground pin that's available here and make the connection directly to Arduino. Or you have another option of using the 8 volts that comes out of this battery and connect it to V-in of the Arduino. For now, we'll use the 5 volts and ground. So I take the 5 volts and connect it to here. And there's also a pin here, which is 5 volts. And this is the ground. Now there's already a program in my controller that's ensuring that it runs well. The major challenge with this battery, which most of you have faced, in fact, students in the afternoon batch, which is like 2 to 4 p.m., would have already faced this problem in class. This is because the battery gets shut down every time you're drawing more current, especially because I'm giving a reverse command to this motor. So that you see that Arduino gets reset and it blinks. See this here? It's getting reset. It's the same thing that I do whenever I press reset. For this, what I can do right now is to remove this 5 volts from here. The ground has to remain. Please ensure that the ground between any boards, any logic boards, any controllers, any circuits that you connect, you're using multiple circuits in your project. Always ensure that the ground of all the circuits are common, which is like the 0 volts of this circuit and the 0 volts of this circuit or this board has to be connected to each other. Only then there will be a logic flow between each of them. So what I do is I connect the ground pin here, from here to the ground pin on Arduino. I could do it here, or there's a ground pin here which I'm connecting. Now all I have to do is give a 5 volts to this. So I will just take my USB port and then I'm going to connect it here. Now the program that we've written here is for the motor to go forward, reverse. Okay, it says, okay, it goes right, left, forward, reverse, and stop. Right, left, forward, reverse, and stop. I'm just gonna take this off for a moment. Yeah. Now, how do we write this program for the robot to go forward, reverse, right, and left? Is quite simple. We've identified 4 pins that we'll be using for controlling this motor. When we actually studied the motor driver last class, we decided that I1, I2, I3, and I4 will be connected to 2, 3, 4, and 5 on the Arduino board. So the program that we would be writing will involve pin number 2, 3, 4, and 5, and we'll be declaring that as output. And once that is done, by making I1 high and I2 low, we will be able to make the left motor go forward. By making I3 high and I4 low, we will be able to make the right motor go forward. Now, this is crucial for us to understand, is whenever I make I1 high, I should have my motor rotating forward. If this is not the case, then we will miss out on our program. So that I'll have to check with the connectors. So I just connect I1 to 5 volts and see if the motor goes forward. It does go forward. So in your case, this is forward. This is the forward of the robot. It's going forward. Yes. And then I take the wire that I had connected to I2, which is the gray wire, and I give it a 5 volts. The motor goes reverse. Now I'll connect I3 to 5 volts. It goes forward. And I4 to 5 volts, and it goes reverse. It's quite clear that we will be able to control it with these 4 pins. So I'm going to just connect it back to 2, 3, 4, and 5. Write the program again. Okay. White, gray, black, and brown. White, gray, black, and brown. There's something. Okay, we're good. So I've made the connections. Is there any other connection that I have forgotten or not made? None of it. Ensure that these 2 pins here, it's on EN and plus 5E are connected. Enable and plus 5E. And here, direction in pull up or pull down, it should be in pull down, which is IN and 0V is connected. We'll explain what this means in future sessions. Okay, now we're good to go. Go to program. I'm just going to put this robot on a raised platform so that's easy for me to say control it. Otherwise, it's going to just fall off again. I'm just going to put the battery in the front so the weight is balanced. Let me see what I've done. I'm just going to put the battery in the front and this here. The weight is balanced. Oops. Okay, and now we're good to go. Does it fit the frame? Okay, I'm going to put it this way. Good. Right. Now I'm going to just connect the motor, the USB cable, and expect the motor to be rotating. I'm just going to open up the program. I'm just removing this ground here. I see there's no change. So I'm just gonna remove the battery. To see that this goes off. All right. Okay, what's happening to Arduino? Okay, cool. So we have the sketch, and we're just gonna write the sketch again. And I1 equal to 2. I'm just doing it a little fast so that you know that it could be done faster. 3, 4, and this is 5. And in void setup, what I do is I say pin mode I1 is output. This is required only because I1, I2, I mean all of these pins 2, 3, 4, 5 could also be input or output. They have two functions. So that's the reason I'm defining it as output. I just have to take this, right? Control C, right, good. And then I just have to make this I4, 3, 2. And void loop. Yeah, I have to put my main code here. So what I do here is say digital write I1 is high. And when I do this and upload the code, I should see that only my left motor should go forward. To save it, I say motor control and today's date. First getting uploaded. This is going to connect the battery. So put our system seems to be a lot slower than before. Did it upload? Yes, it's uploading. And you see that the left motor goes forward. Right? It's quite simple there. And when I make I2 as high, and gets uploaded, it goes reverse. How do I show that it's going reverse? It's going reverse. Is that okay? Let me do one thing. I'll just put a sticker on this. All right. So what I do is similarly I3. If I make it high and upload, I see that the motor here starts rotating. It's going forward, and when I make it I4, it goes reverse. It's going reverse. Now, one thing we'll have to keep in mind is like when we do use any of these pins, we just have to use them in combination. So if I use I1, I also use I2. And when I make both of these pin high, what's going to happen is the code gets uploaded, but it's going to stop this motor. But you see that this will be orangish because it's a mixture of green and red. It's going to be orangish because I made both high, and if I make one of them low, the motor is going to go forward. And I make this low and upload the code. You see that the light is off because both the pins are low. And when I make this high, I'll see that it goes reverse. Green, and it goes reverse. It's the same case with putting in the other one. So just copy this, and I just make this I3 and I4. So now both the motors are supposed to go reverse. Forward, okay, reverse. What happened to the other one? I3 is low and I4 is high. Okay, hold on. 7 kV. Okay, the battery seems to be low. I'm just going to change this battery. Okay, very fast. We're going reverse, 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 and reverse. Now, I got it going reverse. I also wanted to go forward. I would put a deal. Okay, let me just copy this and make it go forward, and then see why it's not. What's happening here? So all I have to do is make this high and make this low. I could also change this number to 4 and this to 3. That's also a way of doing, but then we would prefer you follow a standard so that next time somebody looks at your code, they'll be able to follow it. So we just bring it back and then I change here. As long as you remember what you've done, great. Go ahead and upload the code. It's quite an interesting thing to notice here. The motor goes forward, backward continuously. That's the reason it stops. And it's quite difficult for me to even rotate it compared to what it was earlier. So what I would rather do here is put a delay so that it's visible for me. Say, I do about 500 milliseconds. And then I give a delay here of 500 milliseconds. And then upload this code. So it goes forward, reverse, forward, reverse. Okay. Pretty much. So this is where I make the robots go forward and reverse. Now same thing, if I have to make it go right and left, I'm going to copy this and paste it again. And I would say, for my robot to go right, I want my left motor to go forward. This is good. And the right motor to stop. Let's upload the code. So both goes forward, reverse, and yeah, it's very difficult for you to see it. So I'm going to make this about 1 second. So you see the right turn. It's quite clear. Forward, reverse, and right turn. Forward, reverse, and right turn. Forward, reverse, and right turn. Let me just stop and put. Is this something that's visible? As long as it stays, we're fine. So put this on this. There's some rubber adhesive. I didn't get a tape, sorry. Okay, good. So I just connect the battery and you'll be able to see it. Oh yeah. Okay, let me just stop this. Doesn't make any sense because it's going too very fast. And I'm going to upload this code. So it goes forward for a second, reverse for a second, forward for a second, and takes the right turn. reverse, forward, right turn, reverse, forward, right turn. All right, how do I stop it? It's primary, very important. So I can copy the entire thing and I paste it, and I wanted to stop for say about 2 seconds, and I make each of these things low and upload the code. So it goes forward, reverse, right, and stop. Forward, right, and stop. Reverse, forward, right, and stop. All right, good. So we will be able to make our robots go forward, reverse, straight, right, and all of that. And last class, we also calculated the speed of the robot. What we use, okay, how do I make this robot stop forever? So if I have to make the robot stop forever, I'm going to put this in comment lines and put this in comment lines. Yeah. And then upload the code so the robot stops. All right, good. Now the robot stopped. So it doesn't make any sound when you're talking. Yeah, we calculate the speed of the robot by measuring the diameter of this wheel. The diameter of the wheel was about 7 centimeters. So our calculation said the circumference of the wheel, circumference of this wheel will be about 22 centimeters. And 22 centimeters, this is going at about 200 rotations per minute. So this should go about 4,400 centimeters per minute. That's about 4.4 meters per minute. Sorry, 4.4 meters per minute. No, sorry, let me come again. So it goes about 22. Okay, I'm going to do this calculation for you. So this is about 22 centimeter. And 22 centimeters per second is what the speed is. So what we will be doing is a circumference. So we know multiplied by 200 is going to give it RPM. That's about how many centimeters per second. So that's going to be about 4,400 centimeter per minute. That's about 44 meters. So 44 meter per minute, and then you do all the calculation, you should get about 2 to 3 kilometers per hour. That's the speed of the robot. It might look very fast, but it's not very fast. It's about 2 to 3 kilometers per hour. Now, once we're done with this calculation, we can actually know if I want to make my robot go straight and then take a right turn, how do I do it? If I want my robot to take a right turn, then I might keep my delay as about, say, 20. If I keep the delay of 20, okay, let me do this. I'm going to create a code I'll stop my motor for some time, and then I'll make it turn right or left, all right? So let me make it turn left. For making it turn left, I need to stop my left motor and make my right motor go forward. And then I'll do this just for about 20 milliseconds. Let's see how this looks like. It stops for 2 seconds and then just rotate. Do you see the motion of this? 20 millisecond, how much it rotates? Now for this to rotate a complete 90 degree, we use the formula S is equal to R theta. R is the radius of this robot. So considering this is the circle, the robot going around like this. This will be the radius. This distance will be the radius. We're going to do this calculation in the coming class. So I calculate how much. So I actually keep it on the table and check. So the robot's going to turn a little. It's just going to turn a little. In fact, it's just slipping. You can just see that it's turning a little. Okay. So if I have to make this, I think I have to make it about 100. So it might turn 90 degrees. And let's see if it turns 90 degrees. All right. Logically, this will not because it's slipping. See, the wheel is slipping. This is because there is no weight on this wheel. So by this we calculate how much distance or how much angle this motor can rotate when I'm rotating it for over 100 milliseconds. So let me just stop this. Load. If you see, this wheel is quite slippery. It's not going to give us a very precise direction because a lot of cases what happens, it rotates for 10 seconds, but then it probably wouldn't have moved so much because it spends a lot of energy in just overcoming the inertia, its own weight. So we could use rubber tires. These are not rubber tires, these are plastic tires. We could use rubber tires, or we could have a rubber grip around this to give us more grip. And not just that, we could have some more weight on the robot, so it actually presses the wheel down to the floor so that it doesn't slip. So all we have to do is for this to rotate from here, it's about one complete rotation. So we calculate the distance from here to here, which is nothing but 1/4 the circumference that is of this robot rotating. This makes a circle. It's 1/4 of that distance. You calculate the time required to cover that distance and you will be able to figure out. Now there's another way which we could do it to make the robot turn right. That is, I would make this low, which is like left motor stops, or I could make the left motor go reverse and the right motor go forward and upload the code. Now you see what happens. I'm just going to disconnect the USB cable and going to connect this here. So it's going to give you. Okay. So this distance, this time is about 200. I'm just doing it very intuitively, not by doing any calculations. Okay, 200 also. Okay, there's a problem uploading because I'm not connected. This, let me take this out, and then connect this. Load. All right, I think this is good. We'll just connect the 5 volts back. Okay, it's almost 90 degrees. Yeah. So this is how we make the robot go right and left and straight and reverse. All combinations is possible. Now you could make it go in a straight line and then maybe move out of the room, or maybe another thing that you could actually do is take a marker like this, connect it in front of the robot, and make it draw things. Like we discussed last class, please carry a sketch pen or a marker when you come to the class. The different classes. We're just going to mount it here on the robot, and we're going to make it draw stuffs or draw things. So that's what we're going to do this class, and this is what we would be covering in this session. I hope you've got this. We've done, in fact, 3 sessions on just doing motor control, because this is like the fundamental thing that you will have to know in robotics. How you control a motor. A motor is actually an actuator. I mean, there are a lot of types of actuators. Not all robots have wheels. Wheel is just one way in which you could make a robot go forward or reverse, I mean, in any direction. But there are different other mechanisms to actually have your robot or car or any of your vehicle to move forward or reverse or move different directions. So one of them is wheel. So we primarily work on the wheels because it's easy to understand and it's one common thing that we use. Now, now that we have spent about 3 classes just on understanding how to control the motor or to get things happening, the next session what we will be covering is how do we do speed control. It's not a very difficult thing to do speed control. In fact, I would say it's very easy. All I have to do is replace digital write with analog write, and then instead of low, I write any value between 0 to 255. 0 to 255. So these are different speed levels that you can actually control your robot. Now we'll be covering this in the next class. This is just giving you an overview. So how we do it. And for this, one important thing is the pin that you're actually choosing to be analog write has to be a pin that has a till symbol on it. If you look closely, pin number 3, pin number 3, 5, 6, 9, 10, 11. These are 6 pins that are PWM, which is pulse width modulation. These can give a varying voltage to your Arduino or your motor driver board. So this you could use to control the speed of the robot. We'll be covering this in the coming class. And that's it for today. If you have any questions, you could ask, or you could write to us, or you could just send us a WhatsApp message and then we'll reply back. Okay, so I'm just gonna stop this screen sharing now. Any questions you could ask, or we will be closing the session sometime. Okay, hope everything is clear. We're gonna end the session. Thank you so much for being part of this session. The recorded session will be available online on our YouTube channel. For more of these videos, subscribe to our channel and you'll be alerted whenever we have a live session happening. And have a great week. See you Saturday.